Hi, this is Mrs. Marita. Welcome to section 2.2, point slope form. We're on page 36 of your student companion book, and just a quick recall. So recall that our slope-intercept form, y equals mx plus b, was what we used in the last section. Now we have a new form. This new form is called your point slope form. Not a very creative name. This is going to be a form that has the point and a slope. So the way we write this, and we're going to skip example 1 right now, is y minus y1 is equal to m times, now parenthesis, x minus x1. Your m is still your slope. That'll always be your slope for us in Algebra 1. And then the point, this could be any point. So our point here is just an x1, y1. In your slope-intercept form, we still used our slope m, but the point, well, it was your y-intercept. So that was a special point. But for point slope form, what we're working on today, this point x1, y1, this could be any point on your line. So we're going to do a different example 1. So take a moment and copy this into the margin. We're going to try. Write an equation of the line that passes through the point 1, negative 2, and has a slope of 2/3. So to write this equation, we're going to use our new point slope form. So that equation is the y minus y1 is equal to m times x minus x1. So your y and your x, this y and this x, those two are always just going to be your variables. Every equation of a line, well, has at least an x or a y, but right now these equations have an x and a y. So we're going to write these and plug in our point and our slope. And so the y will just remain a y minus, well, now we need to find, well, what was the y1 of our point? So up here we have an x1 and a y1. So we have y minus negative 2. My y1 was negative 2. Is equal to the slope. We just plug this in, 2/3. And then the x remains an x. We're just going to plug in the ones with those subscripts. And then minus my x1 up top, that was a 1. Now we're not going to do too much simplifying. We're going to leave this in a point slope form, but we do want to simplify this double negative idea. So we'll say y plus 2 is equal to 2/3 x minus 1. So when they ask you to write an equation, this is your final answer. Later, we'll have some equations or some problems that ask you to write an equation, but they specify it in slope-intercept form. Then we'd have to go back to our y equals mx plus b. But this just says any equation, so happy day, we're done. For example 2, we're going to do a similar process, so write an equation in point slope form, but in this example, they're giving us 2 points. So we want to write the equation of a line that passes through 2, -1, and -3, -3. So there's going to be one additional step. So first, we need to find the slope. So we're going to use our slope formula, y2 minus y1 all over x2 minus x1. And it doesn't really matter which point you call which. We'll call this the first point though, x1, y1, and this will be my x2, y2. And so we'll plug these in. So 3 minus -1 all over -3 minus 2. And then we'll simplify. 3 minus -1, we get 4 all over -3 minus 2, -5. So now that we have our slope, this problem becomes very similar to example 1. So we'll plug this in. Using our point slope form, y minus y1 is equal to m times x minus x1. And there's really 2 answers. You could pick either point for your x1, y1. So I'm going to do y minus, we'll pick this first point. Oops, it's kind of messy start. So we'll pick this first point, y minus -1 is equal to our slope. I'm going to put the negative up top, -4/5 times x minus, and then x1 was 2. And then we'll just simplify this minus and negative. So we get y plus 1 is equal to -4/5 x minus 2. So that's our final answer. Both of these equations are in point slope form. We had to find the slope in this example 2, but then at the end, you just plug in and simplify, and you're done. Moving on to example 3. So now we are, let's see, this is on page 37. There we go. So for example 3, now we want to sketch a graph. So they give us an equation, and this is in your y minus y1 equals m times x minus x1, our point slope form. And so from the equation, we know that our slope is this 1/2, right there. And then we have a point. Now this is not your y-intercept like before, but now we have a point that we want to start with. There's a little trick here though. Be careful. Your equation has this built-in negative. So if we have this x minus x1 and your x here is 3, well, there's supposed to be a negative there. And so our x value is really this positive 3. That can get kind of tricky. And then for the y, your y should have this negative, but there's a positive 2. So be careful. What this tells us is really we had a y minus negative 2. That's where we got that plus 2. We saw that in some previous examples. And so the y1 value is actually a negative 2. So when we plot, we're going to start with our point. So we'll go over 3, 1, 2, 3, and down 2, 1, 2. That's where our point will be. And now we're going to use our slope. So our slope tells us to go up 1, to the right 2. That'll be our next point. So we're going to go up 1 and then to the right 2. And we have our second point. Now we just connect. Oops, I kind of missed. You know what you do when you miss? Yeah, make the point bigger. There we go. And so this equation just wanted us to sketch the graph, and that's what we got. Last example, example 4. Rewrite the point slope form equation from example 4. Actually, let's make this example 3. We'll use the one up above in slope-intercept form. So we want to rewrite the point slope form equation from example 3 into slope-intercept form. Then we'll answer, what does the y-intercept represent in terms of the situation? So the equation up above was y plus 2 was equal to 1/2 x minus 3. So as you can see up above, we're starting with an equation in point slope form. We have those parentheses. And we want to rewrite this in slope-intercept form. Whenever you want to rewrite something in slope-intercept form, you need to isolate the y. So we want to isolate the y. So to get y by itself, the first thing I'm going to do is subtract 2 from both sides. And I get my y by itself. Those cancel. Ooh, but be careful. We cannot combine this -3 and -2. That -3 is in parentheses. There's all kinds of stuff going on. Why did I write extra equal signs? So we end up with y equals 1/2. I'm just going to recopy this. And then the -2. So if we want to combine that 3 and 2, well, first we have to tackle this 1/2. So we're going to distribute. And we get y equals 1/2 x minus, this is just like 3 over 1. So minus 3/2 and then -2. So now we need to combine that -3/2 and -2. Maybe we'll do some scratch work over here. Let's see, -3/2 minus 2. Well, if we want these to be a common denominator, let's see, 2 over 1. So I need times 2, so times 2. And we get -3 over 2 minus 4 over 2. So this works out to -7 over 2. So when we rewrite this to simplify, we get y equals 1/2 x minus 7/2. So this equation is what they desired. They wanted us to rewrite. So we started up here with an equation up here in point slope form, and now we've manipulated it. We rearranged everything, and this is actually going to be the exact same line. If we graph these, if we used a calculator or any online graphing software, these two lines would be the exact same. They're just in a different form. The red line, the top equation, is in your point slope form, and then this bottom one in the box, that's your slope intercept form. And then this last part of the question, what does the y-intercept represent in terms of the situation? Well, this will be for any situation. Your y-intercept, this is where the line, oops, that's messy. Come on, Miss Marita. This is where the line crosses the y-axis. There we go. That's it for section 2.2. Make sure you copy down all your notes and bring your questions to class.